These are the 2.1a notes for PreCalc. This lesson is all about functions. So our essential question is, what is a function? So first we had to talk about what is a relation. A relation is just a pairing of numbers. Just two numbers paired together. In math, we have 4 different ways that we express relations. So all of these you've probably seen before. Ordered pairs is just when you have the x and the y. So the x comes first, the y comes second. Those are your ordered pairs. Next, you have a mapping. This is just the arrows being drawn to link one x value to the other y value. Then you have a table of values. Same thing, x and y. And then finally, you have a graph. So those are the 4 ways that we express relations. Of those relations, we have 2 things that we need to talk about, domain and range. Domain is your x values. Those are what we call the input values. Range is your y values. They're what we call the output values. When we list the domain and range, we are just going to make a list of the numbers. So domain is your x, range is your y, and we're just going to list these out. When we list them in order, small to large. And then we do not repeat anything. So in order, small to large, and no repeats. So for problem number 1, we have a list of ordered pairs. Our domain is going to be all of our x values. So the 5, the -8, the 1, and the -3. And we're going to write those in order from small to large. No repeats. -8, -3, 1, and 5. That would be my domain. The range, same thing, but the y's. I've got my 3, 5, 7, and although I have 2 7s here and here, I do not want to write them twice. Problem number 2 is a mapping. So you've got the 3 and the 5 being matched up to the numbers on the right, the -3, the -5, and the -7. See if you guys can do the domain and the range. List them in order from small to large, no repeats. I'll give you just a moment. All right, your answer should look like that. Your domain is 3, 5. Your range is -7, -5, and -3. So relations is just any pairs of numbers kind of grouped together. Now, a function is a very specific type of relation. So a function is a special type of relation that for each input, x, there is exactly one output, y. I always explain it as the x's can't cheat. So this is kind of a very basic way of understanding functions, but it is very helpful. So this is based on the definition. So for each input, there is only one output. So for each x, it has to be only paired with one y. So if it's a function, then the x's aren't cheating. Let's look at problem number 1. Tell whether each example is a function, yes or no. So on problem number 1, 2 is paired up with 1. The x's is not cheating. The 2 is paired up with 1. But when you look at 8, 8 is paired up with 3, but 8 is also paired up with 5. So for each input x, here it has 2 outputs, the 3 and the 5. So we would say, no, that is not a function. If you want to think about it a different way, think about it as like a dating relationship. 2 is dating 1. That's all good. 8 now is dating 3 as well as dating 5. So the x is cheating. So that is not a function. Problem number 2. 1 is paired with 6. 2 is paired with 5. 3 is paired with 7. So the only other way you can think about it is 1 is paired with just 6. 2 is paired with just 5, and 3 is paired with just 7. If that's the case, then yes, that is a function. Problem number 3. -1 is paired with 5, -3 is paired with 11, 4 is paired with 7, and then -3 again. Notice right here what's going on. -3, 11, and -3, 8. That is not a function. 4 is a yes. 5 is kind of a special situation. So the rule about this is the functions, the input has to have one output. They did not talk about how the output has to look. So even though this 3 is paired with 1 and the 4 is paired with 1, it is still a function. So I'll often explain it. I'll say the y's are allowed to cheat. It's the x's that can't cheat. So the y's can cheat and it still be a function. Take a moment, look at problems 6 through 10, and see if you can decide whether yes, it's a function or no, it's not. I'll give you a little bit of time. Six is a no because of the 8. 7 is a yes. 8 is a no because of the -1, paired up with two different numbers. The input has two different outputs. Number 9 is a yes. Again, the y's are allowed to cheat. You can have more than one output. But 10 is a no. 3 is paired with 2, and then 3 is paired with a different number, 8. All right, nice job on that. So once we've kind of talked about functions, then we're actually going to work with them. And most of the math that we do in PreCalc is dealing with functions. So how do I evaluate functions? So you're going to be given a function, which is just another word for an equation. So oftentimes people will write f of x as y. F of x is what we call function notation. F stands for function. And that type of notation is very helpful as you move up into higher level maths like calculus. So they're just going to kind of get used to this function notation here. So let f of x equal 3x plus 5. And they want us to evaluate the following. If they put a number on the inside of a parentheses, that's pretty much just telling us plug in 6 for the x. Plug in 6 for the x. So notice it's a 6 right here. It used to be an x. So we're going to put a 6 right there where that x used to be. 3 times 6 plus the 5. (18 plus 5, 23. For part B, they're asking us to plug in 7x for the x. So all that this is doing right here is just telling us that information. We don't actually have to do anything with that. As long as we're going to plug in 7x for the x, we should be good. So I'm going to plug in 7x where the x was. Multiply that to make 21x. And since 21x and 5 are not like terms, that is done. So you're not solving an equation. You're not trying to figure out x equals. You're just trying to simplify an expression. Problems, part C. If you have a number in front, you want to multiply or distribute. If you have a number in front, you want to multiply or distribute. The 4 will go in front, and we'll put the entire function, the entire equation, into a parenthesis. 4 times f of x, 4 times the equation. And you distribute to make 12x plus 20. And there's your answer. For part D, it's got two things happening in here. It's got the x plus 2. So we're going to plug in x plus 2 wherever we see the x. And then we're also going to, that negative in front is like having a negative 1. You're also going to multiply by negative 1. So I'm going to do my plug-in first. I'm going to do 3 times x plus 2 plus 5. And I'm going to save my multiply by negative 1 till the end. Distribute. Combine your like terms. And once that's as simplified as I can get it, then I'm going to go ahead and multiply by negative 1. So just like we did on part C, I'm going to put a parenthesis around it and put whatever number I need to multiply out in front. This will get you negative 3x minus 11 for your final answer. So you do the plug-in first and the multiply second. On problem 2, they're giving us a new function. So this one's a little more complex, 2x squared minus 4x minus 3. These things down here mean the same thing. So when we put a 3 right there, make sure that you plug it in. So anything inside the parentheses means plug it in. Anything inside the parentheses means plug it in. So I'll plug in a 3. I'm going to plug in a 3 in several places. I'm going to plug it in for that x as well as for that x. People will often ask me, do I have to plug it in for that x right there? Not really. That's kind of what this is. So they plugged this 3 in for that x right there, and that's how they got that question. So you are not responsible for plugging in the 3 in for that x. They've already done that for you. So we're going to plug in the 3 carefully. And then make sure you're following correct order of operations. Think PEMDAS. So first is parentheses, but there's nothing inside my parentheses to do. I just have 3's there. So then I move on to my exponents. 3 squared is 9. Once I've done my exponents, I do my multiplication or division, whichever comes first, left to right. I don't have any division here, so I'm just going to do my multiplication. Then I do any adding or subtracting, whichever comes first, left to right. So 18 minus 2, and then 6 minus 3 is 3. For part B, again, we have something inside our parentheses. So we're going to plug in a negative 5x every time we see an x. It'll look like that. And then I'm going to follow the same order of operations I did on the last one. This time, though, I have some x's in here. So negative 5x squared. I'm going to kind of pull it off to the side here. Negative 5x squared. Remember, when we square something, it means to multiply it by itself. So really what I'm doing is negative 5x times negative 5x. That should get me a positive 25 from the negative 5 times negative 5. And then x times x gets me x squared. I still haven't dealt with that 2 yet. I was just focused on the exponents right now. I'm just going to bring everything else down. You could do this in fewer steps if you're more comfortable with that. That's fine. Then I'm going to do my multiplication and division. Again, no division. So I'm going to multiply the 2 times the 25x squared, 50x squared. Multiply the negative 4 times the negative 5, get positive 20x. And bring down the minus 3. At this point, I don't have any other like terms. There's nothing for me to combine, so I am finished. For the last one, part C, same thing. We're going to plug in an x plus 1. So I'm doing one of each of these because they're all a little bit different. I want you to see the differences based on what's being asked to be plugged in. So this time we're going to plug in an x plus 1. So same as before, I'm going to deal with my exponent first. The thing about that exponent is it's going to require me, unfortunately, we can't just take that square and distribute it. That's bad. So what we have to do instead, just like we did over here with that 25x squared, we're going to write it twice. And then we can multiply it out. This is something that you will need to FOIL. So remember, FOILing is when you multiply the first times the first. X times x is x squared. The outside times the outside plus 1x. The two inside numbers, inside times inside, plus 1x. And the last times the last, plus 1. People also call FOILing double distributing because you're distributing the x and then distributing the 1. Then combine any like terms you have. These two are like terms right there. So I'm going to bring down x squared, add the 1x plus 1x, 2x, bring down the plus 1. All of that work just for this little piece x plus 1 squared. So I'm going to bring down the 2. I'm going to write my answer x squared plus 2x plus 1 into that parenthesis. I'm just going to copy everything else down. Then I multiply. Go ahead and see if you can distribute that 2 as well as the negative 4. I'll give you just a moment. After I've done my multiplication, now I'm going to combine any like terms, adding or subtracting. So just the like terms here. So I look for the x squares first. I only see this 2x squared, so I'll bring that down. Then I look at all my x's. I have a 4x here as well as a negative 4x there. Those actually cancel out. Then I'm going to combine my positive 2, my negative 4, and my negative 3 to get negative 5. And I'll write my final answer as 2x squared minus 5. The key to these problems is making sure the setup is correct and then just working very carefully to get to your right answer. All right, nice job today. If you have any questions, just let me know.